projects. In this video, we are going to explain about a project titled Electricity Theft Detection in Power Grid with Deep Learning and Random Forest. The project addresses the prevalent issue of electricity theft which poses the challenges particularly in developing countries. This activity leads to the significant financial loss for power companies and disrupts the economic balance of the power market and the safe functioning of the power grid. To combat this problem, the project introduced an algorithm for identifying the electricity theft. The proposed algorithm combined the capability of an autoencoder neural network and random forest to enhance the detection accuracy and effectively identify the method employed by user to steal power. The algorithm is evaluated using the real dataset demonstrated its high intensity in detecting the electricity theft and achieving the accurate classification result. The project aimed to introduce an algorithm for identifying the instance of an electricity theft by combining the capability of an autoencoder neural network and random forest. The objective is to enhance the detection capability for power theft and accurately identify the method employed by user to steal the electricity. The proposed algorithm serves as a valuable technical reference for on-site investigation related to the electricity theft. Furthermore, the project emphasized the importance of ongoing research in acquiring the data on user electricity theft behavior and developing the high-precision algorithm to address this issue effectively. These are the basic requirements that are needed to build this project. Hardware requirements are the operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is reading the dataset. In this module, it is responsible for reading the power consumption dataset. And the second module is pre-processed dataset. In this module, the power consumption dataset is pre-processed by normalization and cleaning tasks and ensure the data consistency and removing any missing values. The third module is train CNN model. This module focuses on training and convolution neural network model using the power consumption dataset. And this CNN model is trained to learn the relevant features from the dataset, and the trained features are then extracted from the CNN and fed into the random forest algorithm to construct a theft prediction model. And the fourth module is train the CNN with random forest. This module, the random forest algorithm, is trained on the CNN featured obtained of the previous step. After that, perform the metrics such as precision, recall, F-score, and accuracy on the model. Train CNN with the SVM on the previous model, and this module also focuses on training the SVM using the CNN features and calculate the performance of the metrics that are used. And the sixth module is train the random forest without CNN. In this module, the random forest algorithm is trained directly on the normal dataset without incorporating the CNN features and calculate the performance metrics too. And the seventh module is train the SVM without CNN. In this module, it involves training the SVM algorithm on the normal dataset without utilizing the CNN features and calculate the performance metrics. And the eighth module is comparison graph. This module generates a graph that visually compares the performance of all algorithms used in this project and provides an overview of how each algorithm performs of precision, recall, F-score, and accuracy. And the final module is predict the electricity theft. In this module, user can upload the test data and the CNN model is employed to predict whether the test record contain instances of electricity theft or not. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder consisting of dataset link, electricity theft dataset and the test dataset. And the model folder consisting of H5 files which contain the deep learning algorithm information. These files can be loaded into the project code during the runtime to utilize the trained model for various tasks. such as making predictions or new data or performing the specific operations. And the electricity theft detection and the test of the Python files, and this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Electricity Theft Dataset button. By this, it redirected to the dataset folder and select the electricity theft folder and click on Open button. Here, we can see of dataset is loaded, and we can see the dataset contains of non-numeric data too. First, we need to convert the non-numeric data into the numeric format. For this, we need to pre-process the dataset. Then click the pre-process dataset button. By this, the dataset is pre-processed by converting the non-numeric data into the numeric data, and the total records found in the dataset is of 17566. And then click on Generate CNN Model Algorithm button. By this, the CNN model is generated on the pre-processed dataset, giving an accuracy of 94, F measure of 94, recall of 94, and precision of 95. And then click on CNN with Random Forest button. By this, the random forest algorithm is generated with the using of CNN features on the pre-processed dataset and giving an accuracy, precision, recall, F measure of 100%. And then click on CNN with SVM. Here, the SVM model is generated on the CNN features by using the pre-processed dataset and giving an accuracy, precision, recall, and F measure of 100%. And then click on Run Random Forest Algorithm button. Here, the random forest model is generated on the pre-processed dataset without using the CNN features, gives an accuracy of 93%, F measure of 93%, recall of 93%, and precision of 93%. And then click on Run SVM Algorithm button. By this, the SVM model is generated without using the CNN features on the pre-processed dataset, giving an accuracy of 96, F measure of 96, recall of 96, and precision of 97. And then click on Predict Electricity Theft button. By this, it redirected to the dataset folder, and we need to select the test dataset and click on Open button. By this, we get a screen like this. Here, the data present between the square brackets or of the test record, and after the arrow symbol, we can detect it as of energy theft for this data record. And for this data record, it can be not detected as of energy theft. In this way, we can detect the energy theft or not by using the deep learning and of machine learning models. Click on Comparison Graph button. By this, we get a bar graph where x-axis represents of the algorithms we used and the y-axis represents of the value assigned for each algorithm. Here we used the 4 metrics. The first metric is of accuracy, orange bar represents of F1 score, green bar represents of precision, and red bar represents of recall. The project concludes that the proposed electricity theft identification algorithm combining the autoencoder neural network and random forest can effectively extract the abstract behavior characteristic of the electricity theft data and establish an early warning model of the electricity stealing behavior. The algorithm has a high detection sensitivity and classification accuracy based on a real data set. The random forest classification model is trained in the original electricity theft data and the defined electricity theft index, and has the faster training speed and the higher classification accuracy than other classification algorithms. The proposed algorithm can provide the technical reference for on-site investigation of electricity theft.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.